Okay, good afternoon, everyone. Let's get going. We'll talk about binomial distribution today. So what is a binomial distribution? So binomial distribution has the following properties. It's a probability distribution. It has the following conditions or characteristics. So the trials can be counted, such as 0, 1, 2, 3. Trials / individual experiments or events, it could be counted. Avoid using the word event, okay? Even though I wrote it down here, I corrected it. So avoid using the word events for this particular case, because we are talking in general about trials. But events become just one individual event or set of events. Okay, so trials can be counted, such as 0, 1, 2, 3. Fixed number of trials, okay? Fixed number of trials. What does that mean? It means that the number of experiments / trials that you're doing or performing is fixed. It does not change. Then number 3 condition, probability is constant from trial to trial. What this means that if you have, let's say, 10 trials, the probability for each trial is constant. So chances of some event happening in each of these trials, or the same event happening for each of these trials, is constant. It doesn't change. And there are 2 possible outcomes, what we call a success and a failure. Okay, these are the 2 possible outcomes, and the trials are independent. That means one trial does not influence another trial. What happened in one case is not going to have any bearing on the next one or the one after, or even the one before that. Okay, so the trials, they don't influence each other's outcome. They are independent. If you have a real world scenario such as this, then you could use binomial distribution, okay? Any real world scenario that has all these characteristics, you could use binomial distribution. Now, there are five characteristics here, or five things about binomial distribution. But the first one, by the way, even though I put it there, you don't necessarily have to mention it, but the next 4 for sure. Fixed number of trials, probability is constant, 2 outcomes, fixed outcomes, trials are independent. All these things consists of binomial distribution. Now, from my experience, I found out that the best way to remember all these features of binomial distribution is to actually do a problem. So I'm gonna do a problem right now. It's an example. And if you remember that easy example, it will be very easy for you to remember binomial distribution and get a very good understanding of what binomial distribution means, okay? So please follow along this example and you get everything about binomial distribution in terms of definition, okay? So let's go ahead and talk about that example. Now, once again, please remember this example and it'll help you. Binomial distribution example. So think of this scenario, a quiz. A quiz. Oops, there's one Z. Quiz has 5 questions. Okay. A quiz has 5 questions and each question has 4 choices. A quiz has 5 questions, but each question has 4 choices. Now, look at the characteristics of this quiz, okay? Look at the characteristics of this quiz and see what characteristics does it have. So you have 5 questions. So let's start off with number 1. The questions are countable, right? The questions are countable. You can count them 0, 1, 2, 3, 4, or 5 questions. So it's countable. There is no fractional questions like 5.75 question. So it's countable 0, 1, 2, 3, 4. Number 2, there are 2 outcomes for each questions. Okay. There are 2 outcomes. You get the question correct or incorrect. That's all that could happen. Number 3, fixed number of questions. That one is actually number 2. I switched it, but it's okay. Fixed number of questions. In our case, how many questions do we have? Fixed number of questions, let's call it n, is equal to 5. Number 4, probability is constant for each question. Probability for each question is constant. Okay, in this case, let's call probability being P. Okay, for each question, there are 4 choices. So what is the probability that you will get the question correct? It's what's it? For each question, there are 4 choices. What is the probability that you will get it right? The probability is 1 out of 4 or 25% or 0.25, correct? So that's what it is. Number 5, independent questions. That means how you answer one question does not influence the outcome of any of the other questions. So how you answer question number 1, it will have no bearing on question number 2, 3, 4, or 5. Or how you answer question 4 is not going to influence the outcomes of questions 3 to 1 and 3 to 1 or 5, right? So you can see all the 5 characteristics of binomial distribution is satisfied by this example of quiz. So that's why I recommend remembering this multiple choice test or MCQ. Okay, sometimes I call it MCQ, multiple choice quiz. Okay, consider this multiple choice quiz with 5 questions, very simple, and each question has 4 choices. This MCQ example would help you walk through all the 4 features of binomial distribution. One is countable, another is 2 outcomes. Either you get a question, each question you either get it right or wrong or correct or incorrect. And there are fixed number of questions in a quiz, which is 5. And the probability for each question is 25% because each question has 4 choices. What if I had 5 choices for each question? Then what the probability would be? I had 5 choices for each question. Then what would be the probability? 1 out of 5 or 20%, right? Okay, good. And each question is independent of any other question. So they are independent of each other. If all of these conditions are satisfied by a real world scenario or a scenario, then we could use binomial distribution, or we call the distribution probability distribution for such a scenario a binomial probability distribution, and it is given by the probabilities associated with individual x values is given by p of x is equal to n c x p to the power x times 1 minus p to the power n minus x. Now, NCX, combination of X items from N distinct items. So this is the combination. Sometimes people, instead of writing 1 minus P, some people write it as Q. So then this formula becomes NCX P to the power X, Q to the power N minus X. All right. So now let's go ahead and play around with this formula. So somebody takes a multiple choice quiz, MCQ. Somebody takes a multiple choice quiz. What is the probability that the person gets exactly 2 questions right out of 5? So remember, your N is 5. So it's going to be 5C2, P is 0.25, X is 2, 1 minus 0.25 to the power 5 minus 2. So if I simplify it, now look, 5C2, we need to simplify it. I'll show you how to. We have done it before, but I'll again do it for you. 0.25 square times 1 minus 0.25 is 0.75. 5 minus 2 is 3. Now, let's do the 5C2. Remember the formula 5 factorial divided by 5 minus 2 factorial times 2 factorial, which is 5 factorial over 5 minus 2 is 3 factorial, then times 2 factorial. Now 5 factorial is 5 times 4 times 3 factorial divided by 3 factorial times 2 factorial, which is 2 times 1. 3 factorial and 3 factorial cancel out. 2 goes into 4 twice. 5 times 2 is 10. Okay, 5 times 2 is 10. So this number is 10 times 0.25 to the power 2 times 0.75 to the power 3. Now, if you simplify it, by the way, if you simplify this, you're going to get 0.25 to the power 2 times 0.75 to the power 3 times 10. That gives you 0.2636. So someone has approximately 26.36% chance that he or she would get 2 questions right exactly. There is a 36% chance that someone would get 2 questions right. Similarly, you could do 4 questions right. What is the probability that someone will get exactly 4 questions right out of 5? So it's going to be 5C4 times 0.25 to the power 4 times 1 minus 0.25 to the power 5 minus 4. 5C4, you can check it, it's 5 times 0.25 to the power 4 times 1 minus 0.25 is 0.75 to the power 5 minus 4 is 1, which is just 0.75. So now if I simplify these numbers, what do I get? 0.25 to the power 4 times 0.75 times 5. That gives me 0.0146. That is going to give me 0.0146. So approximately someone has 1.46% chance that he or she will get this question, 4 questions right out of 5. in a quiz, MCQ, multiple choice quiz. This, by the way, assumption is based on that, the person is kind of randomly selecting, okay? Randomly selecting the answers. But if you have some knowledge, then the probabilities change, of course. The outcome changes as well. So having said that, now you should be able to find probability of x equal to 1, 2, 3, whatever. Okay. So now one question I would like to ask, what values this x can take? What are the possible values that x can take? Remember, x could be 0, x could be 1, x could be 2, x could be 3, x could be 4, and x could be 5. Even though in theory, x could be anything beyond 5 too. However, here x could be at most 5, from 0 through 5. Why? Because remember, the quiz, the MCQ that you are considering, it has 5 questions. So if x is the event that you get x number of questions correct, it could be only 0 through 5. It cannot be 6, 7, 8, 9, 10. Remember, x could be up to 5. Yes, you could have probability of x equal to 6, right? Sure, why not? Probability of x equal to 6, but in that case, that probability will be 0 because you have 5 questions. You cannot get 6 correct. Or as a matter of fact, probability of x greater than or equal to 6, any number like 6, 7, 8, 9, 10 is actually 0. So that is what it is. Now, next, I'd like to bring to your attention is this. So let's say 80% is the passing grade, okay? 80% is the passing grade. So what is the probability that a student passes? How many questions does he or she have to get right in order to pass? So can you tell me probability of passing? Somebody says 4, Dennis, thank you. So we're gonna find probability of x is equal to 4. Great. Is this all, by the way? Anybody else wants to comment on this? Is this all? What if somebody gets 5 questions correct out of, instead of 4, somebody gets 5. Does that person pass or fail?
5 questions out of what?
5.
Then he passes.
Of course, we are talking about an MCQ, multiple choice quiz with 5 questions. If you get 4 correct out of 5, you pass. What if you get 5 correct out of 5? Do you pass still? Of course you do. So you need to consider the probability of x equal to 5 as well. Then what do? You add these 2 probabilities. That's going to give you the probability that someone will pass the quiz. Probability that someone will pass the quiz is probability of x equal to 4 as well as probability of x equal to 5 added together. So that's your probability of passing. Probability of passing is equal to this. So that's how you will do it. Any question, anybody, about this binomial distribution? Everybody okay with it? Okay, so every time you get a question or a scenario where you can fit all of these 5 criteria, you should be using binomial distribution. What are these criteria? The trials, in this case, questions, or in other cases, it could be a drug you're testing, okay, which will be a real trial. is countable, 0, 1, 2, 3. There are two outcomes you can think of in terms of a drug trial, new medication or new drug that a pharmaceutical company has come up with. You could think of it. It has two outcomes, either effective or not effective. A drug could be effective, a newly developed drug, it could be effective or not effective. Fixed number of trials, meaning that is being given to, let's say, 1,000 people or 10,000 people. COVID-19 is going on, so experimental drugs or scenarios involving binomial distribution is very common. When pharmaceutical companies such as Pfizer or Moderna or Johnson & Johnson coming up with new drugs, or BioNTech or something, that German company that came up with the first COVID-19 vaccine. So when they come up with a vaccine or come up with a drug, first they have to go through the trial. The trials are essentially binomial distributions. So what it is, so fixed number of trials, that means they're giving it to 1,000 people, 500 people, 10,000 people, or whatever it may be. Then probability for the trial being, the drug being effective or the vaccine being effective is kind of like the same for the most part for most of the people, okay? And what happens to one patient or one recipient of this trial does not influence other people. So if you're giving a vaccine for an experimental vaccine for COVID-19 to 1,000 people, they are essentially independent of each other. What happens to one person will probably not influence the outcome of other person, right? So this could be a good way of modeling things, the binomial distribution and the new drug or new vaccine. So all these 5 conditions are satisfied for that, and you can go ahead and use this formula to find the probabilities associated with the different X values. Remember, X values are countable, or trials, events are trials are countable. So anyway, let's go ahead and close this and bring the class notes back. So again, to summarize, binomial distribution conditions, trials are countable, okay, 0, 1, 2, 3. Fixed number of trials, okay, fixed number of trials. Probability is constant from trial to trial. That means the probabilities do not change for different experiments or different trials. There are 2 outcomes for each experiment or trial, and experiments / trials are independent of each other. And as I said, please take the word events away, okay? So I meant you can say trials or experiments, both are fine. Most of the times we will say trials. So these 5 conditions are easy to remember if you just think of an MCQ, multiple choice quiz. Think of a MCQ, multiple choice quiz, that has 5 questions and 4 choices, okay? 5 questions and 4 choices for each question. Then you'll be able to get all of them. Technically, as I said before as well, you don't need the number 1. You can just start with number 2, all right? And there are 2 outcomes. There are fixed number of trials, 2 outcomes, independent trials, and probability is constant. Next, we're going to continue, and let's clarify something. There is a typo here. This is sigma square, okay? Sigma square is n times p times 1 minus p. So the mean for a binomial distribution is mu is equal to n times p. The binomial, every distribution has a mean and a standard deviation or variance. So mean for a binomial distribution is NP. N is the number of trials or experiment. In our case, the last example we have had is 5, and probability associated with each trial or experiment was 0.25. So it's going to be 1.25, correct? So the mean number of questions that a student would get correct for this This quiz MCQ that we just have taken, let's say, is about 1.25. What was the mu? Remember, mu is the mean, population mean. At the very beginning of the semester, I said mu is population mean, and X bar is sample mean. Then sigma is the population standard deviation, and S is the sample standard deviation. Remember those things? Remember, I told you that these things are going to be important and you're going to see them. So population mean mu is NP, and population variance, sigma square is variance, and sigma square is variance, and sigma is standard deviation. All right. So sigma square is n times p times 1 minus p. So sigma is going to be equal to square root of n times p times 1 minus p. That's how you do it. So if I ask you for a distribution, what is the mean, mu, and what is the sigma, then you should be able to find the mu and sigma. These are two questions. Remember, I said that I select a list of 500 questions for you, or 250 to 500 questions for you. Okay, so you should be able to remember this. What is mu for binomial distribution? Mu is equal to NP, okay? Or what is sigma? You should be able to find that. Sigma is equal to square root of NPQ. Q is 1 minus P, all right? Q is 1 minus P. So this is what the mean and the standard deviation for a binomial distribution. And then I did the exact same thing here. Let's see. I kind of want you to quickly tell me. I just did the problem, so it should be still very fresh in your mind. So I'm gonna go through this problem quickly. So a student takes a multiple choice test consisting of, or multiple choice quiz, I'll put quiz, MCQ. Okay, that's easy, MCQ, multiple choice quiz. A student takes a multiple choice quiz consisting of 10 questions, okay? And 4 choices for each question. So first thing that you're gonna answer is this. Show that the above situation satisfies all the criteria for the binomial probability distribution. Show that the above scenario or situation satisfies all the conditions for binomial distribution. So let's start off with the first condition, which is what? So I want you guys to help me out. Okay, everybody unmute yourself and talk to me. What is the first? Yes.
Trials can be counted.
Counted. So you could count them 0, 1, 2, 3. Good. Somebody else. So that's one condition. Number 2 conditions.
Outcomes.
2 outcomes. What are those 2 outcomes? When you are doing an actual problem, you should mention what are the actual outcomes. Don't say that there are 2 outcomes. So what are the 2 outcomes here?
Correct or incorrect?
Yeah, simple. You get the question right or what?
Wrong.
Wrong. Sure. In case of drug, the drug is effective or not effective. Okay. In case of some other event, something has happened or something hasn't happened. So if you get the question right, that would be considered a success. If you get the question wrong, that would be considered a failure. So there are 2 outcomes, success or failure. All right. The third condition. What would that be?
Probability is constant from trial to trial.
And what is that probability?
The probability of getting an answer right.
Yes, so I understand what you're saying, but what is that p-value? You have to apply these characteristics in the context of this particular problem.
25%. Sorry, I was muted, my bad.
25%. Good, thank you. What is the question? Condition number 4.
Wouldn't it be that n equals 10?
Exactly, there are a fixed number of questions. And number 5, what is it? Questions are what?
Independent.
Independent.
Independent of each other, right? Questions are independent of each other. So 5 conditions for binomial distribution. Even though I say 5, make it 4, okay? That's probably gonna make your life slightly easier. 4 conditions of binomial distributions. Fixed number of trials. When we say fixed number of trials, implicitly it is meant that you can count, right? Certain number, so it's kind of hidden there. But if you put this countability condition, that's okay too, that's fine. Fixed number of trials, then 2 outcomes, independent trials, each trial has the same probability, or each experiment has the same probability. And when you have all of this satisfied, you're good. It's a binomial distribution, and you can go ahead and use the binomial distribution formula. Find the probability that students get exactly 5 questions right by pure guessing. So you're looking for probability of x is equal to 5, which is gonna be 10 C5, right? Times 0.25 to the power 5 times 1 minus 0.25 to the power 10 minus 5. That's gonna be 10 C5 times 0.25 to the power 5 times 1 minus 0.25 is 0.75 to the power 10 minus 5 is 5. Now you can use your calculator to do this, okay? Any question, anybody about this? All right, next question is this. Find the probability that a student, oh, I got that one. Find the probability that a student gets less than 2 questions right by pure guessing. So less than 2 questions, right? So what does that mean? Probability of x less than 2. So what would that be? I want you to help me out.
Either no questions right or only 1.
Perfecto. Either no question right or 1, which is the same as saying probability of x is equal to 0 means no question right, plus probability of x is equal to 1. Now you know how to calculate these probabilities. How? So probability of x equal to 0. Let me do this one. Probability of x is equal to 0 is gonna be 5, sorry, not 5, it's 10. 10 C0 0.25 to the power 0 times 1 minus 0.25 to the power 10 minus 0. By the way, 10 C0 is 1, 0.25 to the power 0 is 1 times 1 minus 0.25 is 0.75 to the power 10 minus 0 is 10. So your answer in essence becomes probability of x is equal to 0 becomes 0.75 to the power 10. And I think it's a pretty small number. Okay, so 0.75 to the power 10. That's actually not as small as I thought. X is equal to 0 is equal to 0.056 3. So there is approximately 5.36% chance. There is approximately 5.36% chance that someone will get no questions right by guessing. So you do it for x equal to 0. Now you can do it for x equal to 1, and you add these results. That should be your answer. Next, find the probability that a student gets more than 8 questions right by pure guessing. More than 8. So how would I write that one? Anybody else? Probability of x. How would I write? Anybody?
Probability of x is greater than 8 equals the probability of x equals 9 plus the probability of x equals 10.
Perfect. Perfect. Thank you. Who was it? Was it Jessica?
Yeah.
Thank you, Jessica. X greater than 8, which means what? Probability of x is equal to 9. Greater than 8, you cannot include 8, or you should not include 8. Probability of x is equal to 10. In theory, it is plus probability. So let me use a different color to distinguish. Plus probability of 11. Sorry, x is equal to 11 plus probability of x is equal to 12 plus, it keeps going forever. But all of these probabilities are what? 0, because if you have 10 questions, you cannot have 11 right or 12 right. So that's what it is. Now you can calculate this probability using the formula and this probability using the formula, then you're good. All right. Any question, anybody? Last question on this one is this. If 70% is the passing rate, then what is the probability that the student passes the test by pure guessing? If 70% is the passing rate, what is the probability that a student will pass? So how do I find that? So I'm looking for the probability that a student is gonna pass, okay? Probability of passing. 70% of 10 questions is what? 7, right? 70% of 10 is equal to 7. So we need to find the probability of x is equal to 7. But is that all we need to do?
No,
What is it? We need to do more.
you also have to find the probability of x equals 8 plus the probability of x equals 9 plus the probability of x equal 10.
Exactly. Probability of x equal to 10. Thank you, Jessica. So all of these probabilities, because you don't pass only if you get 70%. If you get 80%, you still pass. If you get 90%, you still pass. If you get 100%, you still pass. So you have to add up all of these individual probabilities to get the total probability of passing. That's how you'll do this problem. Okay? Any question, anybody on this? All right. Next is this one. I want you guys to read this problem, take about 3 minutes or so, and figure out the binomial distribution conditions, 5 of them, okay, or 4 of them. Find out the conditions for binomial distribution. This is a scenario where binomial distribution will apply. So I'd like you to read the problem, spend 3 minutes trying to figure out these conditions, and then tell me, okay, after 3 minutes. So go ahead and get started. So what do you got here? So this is a scenario where we could use binomial distribution. A new drug named Curates, okay? It's a new drug. Okay, it's Curates, they're 60% effective, okay? In extending the average life of an AIDS patient by 20 years or more. 5 randomly selected AIDS patients from Africa are treated with this new drug. Answer the following questions based on the above information. Show that the above situation satisfies all the criteria for the binomial probability distribution. Okay? All the criteria for binomial probability distribution. So let's start off one by one. Number 1, who wants to volunteer? So please be proactive.
Would the trials be the 5 people in question? So 5?
Fixed number of trials, n is equal to 5. Sure. Number 2. What is it?
Not constant from trial to trial.
You mean constant. Probability is constant from trial to trial. That is p is equal to point what?
60. 0.6.
See, somebody else. Other conditions.
Does the 20 years count as conditions or no?
No.
No.
Wouldn't it be the 60%?
Excuse me?
Wouldn't it be the 60%?
What is 60%?
0.6.
Is 60%, yes.
Doesn't it have to be like a trial or a study?
It is a trial or a study, okay? There are 4 conditions minimum.
There are 2 fixed outcomes. It's effective or it's not effective.
Exactly. Either it extends life of AIDS patients by 20 years or not. Okay, 2 outcomes. Number 4, the last one.
Or wouldn't that one be the 60%?
Already 60% is here. P is equal to 0.6.
Oh, yeah, my bad.
Okay, all right. What is the last one?
The trials are
Trials are independent. In this case, you'd say what happens to one patient or the outcome of one patient due to this drug is not going to influence the outcome of any other patients. So in essence, the trials or experiments are independent of each other's, okay? So all the 5 or 4 conditions for binomial distribution are satisfied. Therefore, we could use the binomial distribution formula to find the probabilities associated with this scenario, independent trials, okay? In the exam, please do not do this. Do not write, oh, a fixed number of trials, or probability constant, 2 outcomes, or trials are independent. You actually have to contextualize the problem. You tell in the context of this problem, fixed number n is 5. Probability is 60%, either extend life by 20 years or it doesn't. The trials are independent. You shouldn't probably be even saying that patients, okay, do not influence each other's outcome, all right? So that's how I want you to do it. That way, you really are taking these characteristics and applying it to a problem, to a real world problem, and contextualize it and get a good understanding. If you memorize these things, 4 conditions, oh yeah, fixed number of trials, independent, 2 outcomes, and probability constant, and you memorize it, and that's it. You know binomial distribution. Now, you need to apply these things into a real problem. That's when you will understand the true concept, okay? The real concept will come to your mind. All right, next, let's go ahead and do this. They want you to find all the probabilities associated with binomial distribution. So I'll find a few of them and then you can do the rest. So let's go ahead and find the probability of 0 patients extending their lives, okay? 0 patients extending their lives, which is gonna be 5C0, 0.6 to the power 0 times 1 minus 0.6 to the power 5 minus 0. 5C0 is just 5, by the way. 0.6 to the power 0 is 1 times 1 minus 0.6 to the power 5 minus 0 is 0.4 to the power 5. Okay, 1 minus 0.6 is 0.4, 5 minus 0 is 5. So this in essence becomes 5 times 0.4 to the power 5. And that number comes out to be, what is it? 5 times 0.4 to the power 5 is 0.0512. Did I do it right? 0.0512. Oh, no. Okay. 5C0 is 1. Sorry, my bad, guys. This is 1, not 5. So, okay, let me just erase this and this. So this is a 5C0 is 1. By mistake, I said 5. This is 5C0. Okay, 1. So this is 1. So in essence, the answer is 0.4 to the power 5. 0.01024. 0.0102. Okay. So what is the probability that you get 2 questions right? Probability of X is equal to 2. Not 2 questions, right? But 2 patients extend their life. So it's going to be 5C2, 0.6 to the power 2 times 1 minus 0.6 to the power 5 minus 2. So 5C2 is 10, you can check it, times 0.6 square is 0.36, times 1 minus 0.6 is 0.4, 0.4 to the power 5 minus 2 is 3. So if you do the math, it's gonna be 10 times 0.36 is 3.6 times 0.4 cube is 0.064. So 3.6 times 0.064, that's going to give you 0.2304. 0.2304. All right. So about 23.04%. So probability of X is equal to 3 is going to be 5C3 0.6 to the power 3 times 1 minus 0.6 to the power 5 minus 3. 5C3 is 10, you can check it, times 0.6 to the power 3, which is going to be 0.218, by the way, times 0.4 to the power 5 minus 3 is 2. So if I do the math, so 0.6 to the power 3 times 10 times 0.4 to the power 2, enter, is 0.3456. Okay, 0.3456. Next, so let's go ahead and I don't think I need to do any more. You can go ahead and find the probability of X is equal to 4, probability of X is equal to 5, and also probability of X is equal to 1. Exactly using the same process. And remember, binomial distribution probability of X is equal to NC X P to the power X times 1 minus P to the power N minus X. You can use this formula and do these problems. Very simple, very straightforward, nothing complicated. Any questions so far? No questions? Okay.
None.
Okay. So first find all the probabilities associated, which we did. Probability that no more than 4 patients extend lives. No more than 4 patients. So in terms of X, no more than 4 patients means is 4 or less, right? So that means X is less than or equal to 4, which is the same as probability of X is equal to 4 plus probability of X is equal to 3 plus probability of X is equal to 2 plus probability of X is equal to 1 plus probability of X is equal to 0. If you found all of these values, then you can just read the values and add them up. That's one question. So the next question is, find the probability that more than 2 patients or less than or equal to 5 patients are cured, not cured, extend lives, okay? So more than 2 or less than or equal to 5. So probability of 2 less than X is less than or equal to 5. So 2 is not included. Remember, it's strictly less than. So it's going to be probability of X is equal to 3 plus probability of X is equal to 4 plus probability of X is equal to 5. Probability of X equal to 3 plus probability of X equal to 4 and a probability of X equal to 5. Sure. Then you have all of these values here. You just add the corresponding probabilities, okay? Next, find the probability that at least 4 patients extend their lives. At least 4 patients extend their lives. So at least 4 means what? At least 4 means 4 or more, right? So this is where sometimes students get confused. When they say, I say at least 4, they think probability of X is less than or equal to 4, which is incorrect. It actually means just the opposite. At least 4 is not X is less than or equal to 4. At least 4 means X is greater than or equal to 4. At least means what? That number or more. At least, you have at least $5. You don't say probability of X is less than or equal to 5. What you are saying is, if you write this, you're saying at most $5, not at least. At least, so this is at most, okay? And this is at least. So please pay closer attention to at least versus at most, okay? It's just sign is opposite. Students, when I say at most, they would write X is greater than or equal to 5, which is actually at least, whereas at most is just the opposite. So here at most, it says at least 4 people extend lives. So there's going to be at least means X is, oops, sorry. By saying this, I made the same mistake like you guys. At least 4 means X is greater than or equal to 4, okay? Which means X could be 5 plus X is equal to 4. I just wrote it in other order. So at least 4 means probability of X equal to 4 plus probability of X equal to 5. But you have both of these values, then you just find them and add them. That's pretty much it. Any question, anybody, about binomial distribution? This is everything that you need to know about binomial distribution. All right. All right. So that's pretty much where I would stop for the midterm. I will not cover anything new. So that's all for the midterm up until binomial distribution.